Hey y'all, in this lesson we are looking at using powers of 10 to estimate quantities. We want to be able to estimate large and small quantities using a power of 10. The notes are going to look a little bit different in this video just since it is not a required lesson. So our essential question is, when would you use a power of 10 to estimate a quantity? Our first example we will look at in estimating a very large quantity. Janelle is comparing the estimated populations of China and Japan. The estimated population of Japan is 126,818,019. The estimated population of China is shown, 1,402,941,487. How can Janelle compare the two populations more easily? Yes, we know that China has more than Japan, but how much more? We can estimate each population by rounding to the greatest place value. Then write that number as a single digit times a power of 10. In this case, when we round the population of China, we round to 1 billion. 1 billion has 9 zeros, so it will be 1 times 10 to the power of 9. And the population of Japan rounds to 100 million. 100 million has 8 zeros, so we will write it as 1 times 10 to the 8th power. We can then compare these estimated values. 10 to the 9th is more than 10 to the 8th, so 1 times 10 to the 9th is more than 1 times 10 to the 8th. So we know that the population of China is more. Yes, we knew that already. But we could also say now that it's 10 times more because it's 1 power of 10 more. So she can now use these estimates to compare the populations more easily. In your example, light travels at 299,792,458 meters per second. Whew, that's a mouthful. Sound travels at 332 meters per second. So obviously light travels faster than sound. But how much faster? First, round each number to the largest amount, so round 299,792,558 to the hundred millions, and round 332 to the hundreds. How many zeros are in each one? That will tell you the power on 10. And then for each of these, your number out front, this should be a 3. And you can see that here in 3 times 10 to the what is greater than 3 times 10 to the what. So the speed of light is faster than the speed of sound. Fill this out now. You should get in the end 3 times 10 to the 8th is greater than 3 times 10 to the 2nd. In our next example, we are going to look at very small quantities. Matthias used a laser to measure the average thickness of a human hair. A sheet of paper is about 0.0013 meters thick, so very thin. And the thickness of hair we can see from the picture at 0.000177763 meter. How can we compare these two very small numbers? It was a lot easier to see 1 billion versus 100 million. It's not so easy to see what these ones would be because we don't normally talk about our decimal numbers in this way. So we're going to write the estimated thickness of the human hair and the sheet of paper. So you can see in your notes, I've given you 2 columns, one for human hair and one for sheet of paper. You'll round each value to the largest number. So 0.000177763. We're rounding it to that place where the 1 is, but the 7 next to it tells us to round up. So we go to 0.0002. Then we'll round 0.0013. Again, we're going to round to that 1 place, and the 3 tells us to stay the same, so 0.001. We can write this as a power of 10 as well, because these are numbers less than 1. Our power on 10 is going to be negative. So 0.0002 is 2 times 10 to the negative 4, because to get that decimal to be behind the 2, we would have to go over 1, 2, 3, 4 spots. And 0.001, here's my decimal. To get behind the 1, I have to go 1, 2, 3, so 10 to the negative 3 power. That negative exponent tells me that this is a small number. Now, flip your notes over, and we'll compare the estimates. We have 2 times 10 to the negative 4 and 1 times 10 to the negative 3. Because the larger a negative looks means the smaller it is. Same thing with the exponent. 2 times 10 to the negative 4 is less than 1 times 10 to the negative 3. So we can compare this by saying a human hair is thinner than a sheet of paper. Our final example, we are going to look at finding out how many times as much. So this is where I was talking about, like with the population, we could say that China has 10 times more people. So we're going to look at that specifically in this example. We're going to look at the gross domestic product, also called the GDP, of Canada compared to the US. The gross domestic product basically tells you how good is the economy doing in that country. So we can see in our table that Canada's gross domestic product, let's see here, we've got hundreds, thousands, millions, billions, trillions, quadrillions? Did I count that right? Hundreds, thousands, millions, billions, trillions. Yep. Canada's $1,785,387,000,000,000. The US is $17,348,075,000,000,000. So, again, we want to estimate this. Write it as a single digit times a power of 10. So, Canada, we can estimate instead of 1 quadrillion, we're gonna, that 7 next to it tells me to round up, so we're gonna say it's about 2 quadrillion. We're gonna count the number of zeros to determine the power of 10. So if you count all of those zeros, we got 3, 6, 9, 12, 15 zeros. So we have 2 times 10 to the power of 15. Now let's look at the US. The US, that 17 is going to round up to 20. So instead of 17 quadrillion, we have 20 quadrillion. And again, we count the zeros all the way up to here is 15 and 16 zeros. So one more zero, 2 times 10 to the 16th power. Now we can directly compare these two. 2 times 10 to the 16th is greater than 2 times 10 to the 15th. So we can say, and it's graded by one factor of 10, 15 versus 16. So the US GDP is about 10 times greater than that of Canada. If it was 10 to the 17th, then we would say 100 times greater, because that would be 2 tens. So we can talk about how much greater or smaller something is. In your final example, you try this as well. Approximate the number of cars in the world compared to the number of cars in the US. How many more cars are there in the world than just the US? You should estimate the number of cars in the world to 1 times 10 to the 9th power, and the number of cars in the US as 2 times 10 to the 8th power. So we can say that there is approximately factor of 10 wise, 10 times as many cars. Our key concept, summary, you can estimate very large or very small numbers by rounding a number to the greatest place value, and then writing that number as a single digit times a power of 10. So very large numbers, you're going to have a number that's greater than 1, so the exponent is positive, and very small numbers, you're going to have a number that's less than 1, so the exponent is negative. Count the number of zeros to help you determine the power of 10. Your next step with this lesson is to submit the 9.3 notes and do the build 9.3. There is no mastery check for 9.3. Good luck!